Hey, Ben here. I'm the founder of GCP Study Hub, and this is a webinar that I hosted to do a deep dive into the new Professional Cloud Architect exam case studies. I hope you enjoy and subscribe for more. The content here I can kind of push through efficiently, but there are quite a few slides to get through. And my goal here is to equip you with an understanding, of the case studies so that you, not necessarily so that you're going into the questions that show up on the exam with absolute certainty about what the answer should be, but where you get kind of 80% of the way there. You don't have to think about what the problems or what the priorities are of these different companies that are going to show up in the case studies. Okay, so first we've got Altostrat Media, and first before we look at any architecture or requirements, I want you to kind of understand what kind of company we're dealing with. This is the approach that we're going to take with each of the case studies. So Altostrat is a media company. They produce and manage 4 types of content. They've got podcasts, interviews, news broadcasts, documentaries. So if you think about this, right, we're talking about a mix of audio and video files, and we've got lots of them with this kind of company. And when you think about what that means from an infrastructure perspective or a data perspective, obviously that would mean large files, probably diverse formats, and a library that is not stagnant but is constantly growing. So here's what makes Altostrat a little bit different from the other case studies that we'll look at tonight. They are already on GCP, and we're going to look at their architecture in the next slide. But they're running GKE, they're running cloud storage, they're running BigQuery and Cloud Run functions. So this is not necessarily a migration story or primarily a migration story. You're not going to see questions about like, how do we get to the cloud? It's more that they're already there, and the questions are going to be about what they build next on top of what they already have. So what they want to build is an AI-first media platform. They want personalized recommendations. They want natural language interaction. They want self-service support. They want to use generative AI to transform how their audience discovers and engages with their content. And they are also a B2C company. I have that listed here as one of the takeaways. They're serving a diverse audience directly. That matters because it means that high availability is important to them. Low latency is important to them. The user experience is going to be front and center in the requirements. And so keep that in mind as well. Okay, so let's look at what they have in place today. This is their current architecture. We're going to have to go through this from left to right. I tried to make this as simple and straightforward as possible, although it got a little bit difficult to put everything on one slide. So their users make requests. Those requests hit GKE. That's their content management and delivery. GKE is handling the scalability and ensuring high availability for serving all that media content. So this is kind of the front door, right? GKE serves content from and stores content to cloud storage. That's in the middle there. That's where the actual media library lives. All of the documents, audio files, video files, everything. Cloud storage is the central hub of this architecture. And so this is where it gets kind of interesting. When the new content lands in cloud storage, it triggers Cloud Run functions. I have the just Cloud Functions logo there because they haven't all been updated, but really they're called Cloud Run functions now. These are event-driven and serverless, as you probably already know. They're one of the simpler services to be familiar with on GCP, but they're really good for these kinds of event-driven tasks, right? Of video transcoding, extracting metadata, even recommending content. So you upload a new podcast episode, you put that in cloud storage, and Cloud Run functions can automatically kick off to process it. You don't have to manage servers for that. And if any of you were on the demo that I did last Friday or Saturday, you'll kind of know what we're talking about. There are events that can happen in cloud storage that will kick off or trigger cloud functions. And so that's what's going on here. The output from those functions, the analytics and the metadata, that flows into BigQuery. That's obviously the data warehouse. This is where they're tracking user behavior, consumption patterns, storing audience demographics. And then GKE also queries BigQuery directly for user behavior. That's where they serve things like personalized content or how they figure out what that content should be. Now, in the bottom left, kind of hiding there, we've got the on-prem systems that are important here. These handle content ingestion and archiving. They are slated for migration in the future. That means that there is going to be this hybrid connectivity requirement lurking here as well that we'll talk about, even though most of the architecture is already in the cloud. And among the requirements is not necessarily the migration itself. So what I said on the first slide is still valid, but they're just kind of generally interested in migrating this in the future. But until then, they need this high-speed connection to on-prem. And then for identity to authenticate users, they are using Google Identity plus some third-party tools. The description here is pretty vague in the case study. And then for monitoring, they have cloud monitoring plus Prometheus. And the fact that they're running Prometheus along cloud monitoring is a little bit of a hint, because if you have been studying with my course, you'll know that managed service for Prometheus is a thing that is tested on the new exam. So I suspect that one of the questions around this case study could or will be to move to managed service for Prometheus. So the main thing that I kind of want you to take away from this diagram is the core pipeline here. Content going to cloud storage, triggering Cloud Run functions for processing, storing data in BigQuery for analytics. That is the backbone. The hybrid connection to on-prem, and then the monitoring needs with Prometheus as well. All right. So first theme for Altostrat is AI transformation. We're going to go through 3 themes for each of the case studies. The 3 kind of themes in each of the lists of business and technical requirements. I'm trying to summarize these for you. So the first is AI transformation. This is kind of the biggest one. Over half of the requirements in the case study map back to AI. So walk through each pairing. We've got summaries. The case study says that they want to kind of automatically generate concise summaries of media content. That's, again, podcasts, video, audio, documents. So that would be multimodal. So the solution is likely Vertex, some combination of Vertex AI, or Vertex AI with Gemini, because Gemini can take in audio, video, and text and produce summaries from all of them. Potentially using some of the pre-built APIs for that are available in Vertex AI, but really Gemini should be able to do a lot of what they're looking at. That's kind of what Google is boasting about as well. Next is metadata extraction. So the requirement to extract rich metadata from media assets using NLP and computer vision. Again, these are those pre-built AI APIs that we're talking about here. Vision API, speech to text, NLP API. That's probably where these are going to be most helpful, not necessarily generating the summaries. Chatbots. So they want to enable natural language interaction with the platform and 24/7 user support as well. I could see this mapping to either building agents in Vertex AI or using Dialogflow CX. It's a little bit unclear to me how much Google is still counting on Dialogflow as like a solution here. They were pushing it so hard for years, and it technically is still part of their like contact center AI offering. But it's because agents are becoming more and more popular, I could kind of see them not really emphasizing that as much and focusing on Vertex AI agents as the solution. So Dialogflow CX is for structured kind of multi-turn conversations with defined flows. And then agents are the newer, more flexible approach that use LLMs directly. More likely to be agents probably on the exam, but I could see Dialogflow CX being, I wouldn't be surprised if it's Dialogflow CX as well as one of the answer choices. They want to be able to detect inappropriate content. They need to detect and filter harmful content. So the Vision API can be useful for this. They have this feature called Safe Search that can take in images and video frames and detect these things. But since they also have audio and text content, you might need other models, like a custom ML model for these formats. So I would distinguish between those two, whether the question asks about images and video or whether it's about audio and text. And then, the case study also mentions actually the video intelligence API that could be relevant here as well. But the video intelligence API doesn't actually have that safe search like feature in it. So I could see Google touting the safe search feature, but video intelligence is meant for video specifically. So if the question mentions video specifically, then video and video intelligence is one of the answer choices. Then I could see video intelligence being the answer choice, or being the correct answer. And then finally, we've got recommendations down here. So being able to personalize content recommendations. The more precise answer here beyond Vertex AI is probably Vertex AI Search, and the recommendations API, which is kind of the purpose-built service for this. But BigQuery ML is possible as well. So if the exam gives you both options, I would lean toward the purpose-built one. Because it requires you to do less work. I would lean toward the recommendations API if that is listed and that's part of, or that's available through Vertex AI, or Vertex AI generally over BigQuery ML. But BigQuery ML is also sometimes used for these recommendations models as well. So the pattern to take away from this slide is that when the case study says AI, your first instinct should be Vertex AI with this. And depending on, the format of the data, or how much they want it to be kind of a pre-built solution versus something that they have more control over, you're either looking at, the pre-built APIs, you're looking at, potentially multimodal needs with Gemini, or you're looking at either like a custom model, or a prefab solution in Vertex AI, like with the recommendations API down at the bottom in Vertex AI. Okay, I'm realizing how much time this is going to take. I'm going to try to cruise through this, because we have 3 themes for each of the 4 case studies. And I don't really mind sticking around, but I did say that this is going to be a 45-minute webinar. All right. So the second theme is infrastructure modernization. This is kind of a classic cloud architect theme with the case study. So, the first thing that I want you to notice here, I'm going to kind of summarize this rather than going bit by bit. Maybe that'll save us some time. Is how often GKE Enterprise is mentioned on this slide. So it appears in 3 of the 6 rows that I have here. So that's not a coincidence, right? There is a strong possibility that this is on the exam related to this case study. It used to be called Anthos, but now it is GKE Enterprise. And in terms of modernizing CI/CD for containerized deployments, Cloud Build can handle the building and the testing. Cloud Deploy handles the delivery pipeline to GKE. These work well together. I have a lesson on Cloud Deploy that I added to the new version of the course. If the exam gives you an option that includes, Jenkins or some other third-party tool, that's probably not the answer, because Google is looking. They're already on GCP, and Google likes to push their managed services or solutions. All right, so I'm going to kind of skip the 2 about GKE Enterprise because I mentioned that already. Let's see, secure high performance hybrid connectivity. So this is what I mentioned, a couple of slides ago. This is going to be dedicated interconnect, and I want you to kind of remember why here. So the case study actually mentions high performance, and we're talking about media files, which are large. A VPN is often put up as an alternative to this, or a distractor answer choice in the questions, and that would be too slow and unreliable for this volume of data. So if the exam gives you cloud VPN versus dedicated interconnect for a media company doing data ingestion, like Altostrat Media, you should pick dedicated interconnect. And among the types of interconnect, dedicated interconnect is by far the most likely to be tested or to be the answer to a question on the exam. Let's see. So config sync keeps your configurations consistent across your clusters. I could see that being mentioned alongside GKE Enterprise with that second to last requirement here. And then in the last row, simplifying infrastructure for rapid deployment. Artifact registry stores your container images. It replaced container registry. And then cloud deploy can automate the rollout, or some combination of cloud build and cloud deploy. It has some overlap with the first row at the top. Okay. Now the second, the third theme here is cost and governance. This one is important because I put this as a theme because there's an executive statement in the case study, and it explicitly says that reliability and cost management are their top priorities. So it's not necessarily in like the technical requirements or business requirements that they list, but there's an executive statement that sometimes is important in the question as well. So let's start with the first two rows, which are kind of related. So optimizing storage costs shows up a couple times in this case study, and if you remember, the data is being stored in cloud storage. So I really would not be surprised if auto class or lifecycle policies pop up, because these are the most common ways to save on costs in cloud storage. Or aside from actually setting the storage class to a cheaper storage class from the beginning. Let's see. We've got reliability and cost management on top of this. So I would set up cloud monitoring, alerting policies, potentially, definitely budget alerts, pretty straightforward. This is kind of bread and butter cost management. The next one is important. So it says that AI systems need to be auditable and their decisions need to be explainable. This is not just about logging API calls. This is about specifically Vertex AI's ability to monitor models and also its explainable AI feature. So model monitoring tracks things like data drift and skew and prediction quality over time. Explainable AI allows you to do feature attributions for specific predictions. It tells you which inputs had the most influence on a given prediction. So I could see that showing up, as they're doing this AI modernization. Let's see, informing content strategy with data. So they already have BigQuery as their data warehouse. The cost angle here is about probably partitioning and clustering. How they can control query costs. So partitioning lets you scan only the data that you need instead of the whole table. You have to be kind of smart with your query when you do that, but that is a strategy to save costs in BigQuery. Clustering further organizes the data within partitions, so both reduce query costs, and that ties right back to this executive statement about cost being a priority. And then we've got consolidation of of monitoring and observability. So I mentioned this before. They've already got Prometheus, and I expect that managed service for Prometheus could be one of the things that gets tested. So then they don't have to run Prometheus servers themselves anymore. It's a pretty straightforward consolidation that reduces operational overhead, and that's something that you basically enable in Kubernetes. And I do have a lesson on that in the updated version of the course. Okay, so this wraps up Altostrat, the three themes, right? We've got AI transformation, infrastructure modernization, and then cost and governance, which I kind of chunked together. Let's move on to Cymbal Retail. Okay, Cymbal Retail is a little bit of a different kind of company, different set of problems. It's an online retailer. They sell a large assortment of products across multiple retail sub verticals, and they're growing fast. So think of a company that is like an Amazon marketplace, but struggling to keep up with its own scale. There are four things I want you to focus on here in terms of just like who Cymbal Retail is. We've got that the product catalog here is massive and hard to manage, so that's going to drive AI requirements, data requirements. Second, they span multiple verticals. Consistency across the categories is a challenge that they list. They have an IVR call center where human agents are manually entering orders when customers can't complete transactions online. That is expensive and slow. Fourth, their web storefront is a custom-built app that just queries relational databases for product names and categories. So this is pretty basic. But if we look at the takeaways from this, they have a legacy environment that is very messy. They've got different databases. We'll see that in the next architecture diagram. Old file transfers, ETL batch processing, 3 separate monitoring tools. There are actually some similarities between their architecture and the last architecture that we looked at, although it's not in GCP. And there are 2 completely disconnected customer paths. There's the web app and there's the phone call center. These don't talk to each other at all. And what they want to do is they want to use generative AI to enrich their catalog. They want to do conversational commerce, and they want better product discovery for customers and for agents. And so the case study actually names a specific Google product, Discovery AI. I'm actually not familiar with this. I came across this in the case study. But when Google names a product in the case study itself, that's a sign that could show up in the questions about this case study. Okay, let's look at how this environment is structured. Let's follow the 2 paths. On the top path, right? Pretty straightforward. Customers browse the custom web app, which runs on Kubernetes. It queries the data layer. This is where you see the siloed data. We've got 4 databases. MySQL is the product catalog. We've got a Microsoft SQL Server for the catalog, orders, and customer data. We've got a cache layer. We've got MongoDB as the document store and also for product data. These are data silos. There is no unified view of the customer. And then customers can also call in. They hit the IVR system that routes them to the appropriate human agent. And those agents manually enter orders into the database, or they get data from the databases. So, I mean, this is how a lot of systems currently work, but it's very inefficient. And there will be a lot of organizations that probably want to make this more efficient. So that is why Google has designed this case study in this way. A customer calls because they can't check out online. They wait on hold, they get transferred, and then a person types in the order, by hand. So down at the bottom, we've got a note about the on-prem legacy systems. They have SFTP file transfers, ETL batch processing, that's on-prem. And then on the right, we have fragmented monitoring that they're doing. They have 3 different tools that they're using for monitoring. And so you could imagine a goal of theirs being to have a unified view of what their system is doing. So the theme here is that everything is kind of disconnected. Okay, AI-powered commerce is their main goal, their main theme. So they want to generate product attributes from supplier data. The suppliers send in raw information like titles, descriptions, and images. Cymbal wants to turn them into structured catalog attributes automatically. So again, Vertex AI and Gemini could probably handle this. It can take text and it can take images together as input. You can generate image variations, background changes, color adjustments. This is specifically Imagine on Vertex AI. The case study specifically mentions showing the same product in different colors, swapping backgrounds, adding text overlays. That's image generation. And so this is one of the foundation models on Vertex AI that Google has made available. And as kind of a side note, Imagine is actually, I suspect, I think I did some research on this. It is the model that underpins Nano Banana, if you have used that in Gemini. So, Nano Banana is the actual like the product, but in the back end, what actually is creating the images is Imagine. I think they're on Imagine 3 or Imagine 4 at this point. We've got natural language product discovery. So that would probably be Vertex AI search or discovery AI. Again, this is something that was new for me, but this kind of, I suspect that this uses Vertex AI search in some way. It replaces the current approach of just querying relational databases for product names. So it's specifically for these kinds of use cases of product discovery, right? So a customer can type something like comfortable running shoes for wet weather and get relevant results based on your actual product catalog. And it probably uses, like a vector database in the back end that actually, translates or maps on that query to the closest match among all the products that you have. Conversational shopping via virtual agents. Again, this would be either Vertex AI agents or Dialogflow CX. This is the conversational commerce piece. Human in the loop review. This was mentioned in the case study. They don't want AI generated content going straight to the catalog without review. So, there might be a Vertex AI pipeline or associates needing a custom UI to approve, reject, or modify suggestions. That is actually something that like they probably won't they probably won't ask you to come up with like a technical solution. They'll probably just test like that this is important. Like you there are use cases where you should have a human in the loop, that you shouldn't automate away everything in a business with AI. That's actually how I would guess this goes. Although if they do ask for a technical solution, it would need to be probably some kind of efficient UI that agents can access with a Vertex AI pipeline. And then the last one, reducing call center staffing costs. So contact center AI would be the offering here that would replace the IVR and manual agent workflow that we saw in the diagram. Instead of the customer calling and waiting and talking to a human who types the order in, the virtual agent would handle it end to end. And again, Dialogflow CX is part of the contact center AI offering, but contact center AI is like the broad name for the collection of specific services that relate to making a contact center more efficient with AI. Okay. All right. Database and integration modernization. So shouldn't be surprising that this is part of this is one of the themes, because we saw that they just had, they had so many databases that were siloed and not talking to each other. And they also, were not managed. So this is classic. This is kind of classic case study PCA territory, whereas the AI stuff is new. You could have seen this on the old version of the exam as well, this kind of thing. So you have legacy databases. You need to pick the right managed service for each one. So MySQL and SQL Server are both relational. They could map to Cloud SQL. If they need high performance PostgreSQL compatibility, that's when you'd pick AlloyDB. But if it's just a straight migration of MySQL or SQL Server, then they would go to Cloud SQL. And that is as long as the data is less than, I think, like 60 terabytes or 100 terabytes at this point. Which in this case, it should be, given the kind of data that they're working with. In this case, they're not, the data that they're storing in these relational databases. Unlike in the last scenario where we were looking at cloud storage and we were looking at, media files, it shouldn't be on the order of hundreds of terabytes. But if it is on the order of hundreds of terabytes, then it would need to go into BigQuery. Okay, MongoDB is a document store. And so when you have a document store, you have a NoSQL use case, and Firestore is the GCP native option for document store. MongoDB Atlas on GCP is kind of a niche thing that you could also consider if you want to stay closer to what you already know. But again, GCP, they like to tout their more managed solutions, and Firestore is more likely to be, I think, the answer on one of these questions, or listed as the answer choice on one of these questions rather than MongoDB Atlas. So the next one is a pretty straightforward translation from unmanaged to managed. We have Cloud Memory Store for Redis, which can easily take over the Redis workload that they currently have. SFTP file transfers and ETL batch processing is another thing that they're currently doing on-prem. If they wanted to migrate that, they could use cloud storage for the landing of the file, and then they could use either Dataflow or Data Fusion for the processing of the data. And if the exam asks specifically about event-driven data ingestion, you could put PubSub in front of it. So then you have this kind of pipeline again that we saw an example of last week in the hands-on demo that I did. The file lands in cloud storage. It triggers a PubSub message or a cloud function, which is triggered by really a PubSub message on the back end behind EventArc, and that would kick off processing into a database like Cloud SQL or BigQuery. Data silos with no unified customer view. So BigQuery would be the unified analytics layer. So you would still have these different databases, right? But when you're trying to do analytics and build a data platform, BigQuery is what you would probably still use for that, right? All those separate databases would feed into BigQuery for your analytics needs, not necessarily your transactional needs. So then you finally get this single place to understand the customer journey. And then the custom web app that queries relational databases, this is one of the requirements as well. You would modernize it onto GKE. You would back it with Cloud SQL for the transactional data, and potentially replace the basic keyword search with Vertex AI search. So the rule of thumb for database migrations here is to pick the managed equivalent of what they already have, unless the case study gives you a reason to do otherwise. And that is essentially what this list is. MySQL, SQL Server goes to Cloud SQL, Document Store goes to Firestore, Redis goes to Memory Store for Redis. You can easily replace the file transfers and batch processing with cloud storage, and then some kind of pipeline tool. BigQuery would be the data platform, and then the more custom solution down below. All right. This is the last theme for Cymbal Retail. So they already have Kubernetes clusters. You're going to move them to managed GKE. You get automatic upgrades, built-in monitoring. You stop managing the control plane yourself. That is the advantage to moving to GKE. So again, pretty straightforward one-to-one translation. We've got scalability for growing traffic and product catalog. So you would basically enable auto scaling on GKE. Likely, I could see that being a question. And then Cloud CDN is the content delivery network, the managed solution for content delivery on GCP, and that would handle caching static assets like product images that are caching them closer to users so that they can be retrieved and served more efficiently. We've got, so the three monitoring tools that they're currently using, you replace that with cloud monitoring and cloud logging, pretty straightforward. You've got one place for metrics, one place for logs. Data security and compliance more broadly. I could see service controls being relevant here. That is something that has been showing up on exam questions. The DLP API or sensitive data protection, I think, is now the more umbrella term. That scans sensitive data in customer interactions. I could see that being part of it. Just Cloud IAM controlling access, and then Cloud Armor protecting against DDoS and web attacks. Secure data handling for customer interactions down below. So I could see customer managed encryption being part of this, which would give you control over encryption. I could see that being important. Cloud audit logs would also track, who did what and when, just giving you that auditability. So this wraps up Cymbal. There are three themes here. We had AI powered commerce. That was the first one. The second one was the modernization and integration of databases, because they had those like 4 or 5 databases that were all separate and were unmanaged. And then we've got operations and security. Now let's move on to EHR. So this is actually the one case study in this list that is from the previous previous version of the exam. And so, I don't know if the questions that pertain to this case study will be the same as the questions that were on the previous version of the exam pertaining to this case study, but this is the same case study. If you took the exam before, if you were studying for the exam before, this should look familiar to you. Okay, so EHR Healthcare. This is a little bit different from the first two, and I will explain why. EHR is a SaaS company, so they build electronic health records software, and they sell it to hospitals, medical offices, insurance providers. So that means that unlike the first two that we were talking about, which are B2C media or retail, this is B2B healthcare. So that does potentially change the requirements. The fourth thing, the four things that define this case study are: we've got hospital medical offices; those are their clients, right? Insurance providers need to be linked in as well. Regulatory compliance is obviously going to be important, and then they've got their customers themselves are multinational, which potentially has implications. So again, this is something that was on the previous versions of the exam. And so there's actually almost no AI in this one. So, the first two were heavily focused on AI, but EHR is testing you on kind of the fundamentals: migration, disaster recovery, hybrid connectivity, compliance, observability. So if EHR comes up, you're probably not going to have Vertex AI among the answer choices. You should be thinking GKE, Cloud SQL, dedicated interconnect, VPC controls, modernizing the databases, things like that. This is another detail as well. They are hosted in co-location facilities. I have that as a second bullet point here. And so that means that they rent space in someone else's data center, but they manage their own servers. So it's almost like this in between on-prem and cloud, right? Because like the cloud kind of, at least that one of the main advantages of going to the cloud is that you get not just access to servers and bare metal infrastructure, but you get these managed services. A co-location center means that you're renting the servers, but you are not. So it's not on-prem, but you're managing it. You're managing the servers. And one of those leases in these co-location facilities, I think they have two. One of them is about to expire. And so migration is not just like something they're thinking about in the future. It's like urgent for them. All right. So let's look at this architecture. So this flow is a little bit simpler, although there are similarities here, especially in terms of the application and the data layer. So the users are hospitals, clinics, insurance companies. They access a web-based EHR platform running on Kubernetes. The platform reads and writes to these 4 databases: MySQL for clinical data, SQL Server for records, Redis for caching, and MongoDB for application data. And then below that, we have Active Directory. That is how users are authenticated. That manages users, authenticates users, and then the whole thing is hosted across these co-location facilities. So that's why I have the gray box around this. Oops. they're hosted in these co-location facilities, and one of them is about to expire. So this is the trigger for them migrating. And then outside of the co-location facility boundary, we've got the on-prem systems for insurance provider integrations. This is file-based and API-based, and these must remain on-prem. The case study is pretty explicit about that. They are not to be included in any migration plans currently. And then monitoring as well. You can see kind of a theme here. Monitoring is fragmented. They're using open source tools. They are getting email alerts from this, but those are frequently ignored. There's no centralized visibility. Okay, so this is the core theme for EHR. Let's go through it. They want to replace co-location facilities because the lease is expiring, so they need to migrate to GCP. The containers would go to GKE. If they're running it on Kubernetes already, then the container migration is pretty straightforward. And the databases would probably generally go to Cloud SQL, at least for SQL Server and for MySQL. Obviously, as we talked about before, Redis would go to Cloud Memory Store for Redis, and MongoDB could go to Firestore or MongoDB Atlas. They need a 99% availability for customer-facing systems. That is, a very specific number, and it does tell you the architecture. So you would need probably a multi-region GKE deployment with load balancing in the front. A single region wouldn't give you 99.9% for a global customer base, or at least you would definitely risk being below that SLA. And so, yeah, multi-region GKE, not just GKE in general, but multi-region specifically. Adapting a disaster recovery plan. So Cloud SQL has high availability mode, and that gives you automatic failover within a region, right? So so that would be important. Cross-region replication as well would give you protection against a full regional outage. And so for healthcare, you would want both. So what this would look like is you would have another zone within a region for high availability, within the same region for high availability. And then you would have cross-region replication as like a backup if there is a full outage in the region. And then you would, switch the primary instance over to that Cloud SQL instance that's in the other region. Let's see, reduce latency to all customers. So, the multi-region GKE deployment is going to take care of some of this. The cloud load balancing is going to take care of some of this, but specifically what you could do is use Cloud CDN again for static assets, depending on how much there is, if that's added as a detail in the question. Again, use global load balancing. We're seeing that multiple times, so that could be, that's very likely to be part of a question. And then some multi-region deployment with GKE, you would use a multi-region GKE deployment so that the application is actually running close to users. Dynamically scaling and provisioning new environments. So you'd want to set auto scaling in GKE that would scale existing clusters. And then auto provisioning can go a step further and create new node pools automatically based on the demands of the workload as well. Decreasing infrastructure administration costs. So this is kind of the whole point of moving to managed services, right? So if this is the requirement that's being tested, then there's the answer choice is probably going to be just like, move to managed services such as GKE or Cloud SQL. So I could see that being an answer choice. Okay, this is the densest theme here. We've got 1, 2, 3, 4, 5, 6, 7. Hybrid connectivity and compliance. A lot of them have kind of the same underlying answer though, so maybe I can go through this more efficiently. So several of these are going to involve dedicated interconnect, right? Um, the integrations aren't moving when we're talking about the on-prem stuff, but they need to talk to the systems that are moving to GCP. You need that fast, secure, and private connection. Again, you can see similarities among the case studies, right? Dedicated interconnect is probably going to be part of the solution for EHR healthcare. I'm going to skip down to okay. So VPN could be a reasonable option here. I do have that listed here because the bandwidth requirements to other clouds might not require as high bandwidth. So that could be something that is considered. But there's, when we're talking about multi-cloud, there is lots of options there. So it wouldn't necessarily be VPN, but they're actually like managed services within each GCP service that potentially connect it more easily to another cloud. I think there is also another type of interconnect that is made for multi-cloud. I'm forgetting which one it is because dedicated interconnect is the one that is so often tested. But there's partner interconnect, there's dedicated interconnect, and there's one other. Anyway, but VPN could potentially be, a reasonable choice if the bandwidth requirements are low. And when we're talking about regulatory compliance, service controls could create the service perimeter. Customer managed encryption keys could also be important in allowing EHR to control the encryption keys, manage them. DLP API could scan for sensitive health data. That's actually worth emphasizing because it is like that is one of the main use cases of the DLP API. And then audit logs just kind of track everything. So with these, four, you've probably hit most of the requirements for a healthcare software company in terms of security and data security and privacy. The Active Directory here. So this is kind of a classic exam question. There's a managed version of this in Google Cloud where you can actually, sync the directory with Cloud Identity. Cloud Identity works not just with Microsoft AD, but it can federate with other directories as well for user authentication and user management. So if you don't want to use Google's workspace or Google admin, and you have one already, you can sync it with Google's Cloud Identity. Yeah, and it's probably worth noting that the solution is not going to be to like delete Active Directory and move it to Cloud Identity because that kind of migration has a lot of risks with it, and that is specifically why Google has set up these syncs and these managed versions of these popular solutions that are already out there, like Microsoft AD. If you need a secure connection between on-prem and GCP, dedicated interconnect again, potentially private Google access, so that the on-prem systems can reach GCP APIs, without going over the public internet, or if you have a subnet, reaching GCP APIs without going the public internet would be important. Let's see. And then the last two rows are about onboarding new providers quickly, ingesting their data. PubSub and data flow is potentially going to be relevant here. The healthcare API is also worth knowing about. I've never seen it show up on an exam, but it's just, I listed it here because it's like a healthcare company, but it's supposed to be able to handle healthcare specific formats like DICOM for scans, or HL7. These are ones that I've read about being more easy to handle through the healthcare API. But there's kind of no reason you couldn't do that in another way too. But it can just kind of do it natively. Anyway, okay. Last theme for this. Okay. This is, again, this ties to the executive statement, which complained about misconfigured systems. So for consistent logging, log retention, monitoring, and alerting, again, classic, we're going to do cloud monitoring and cloud logging. This replaces their fragmented open source tools with a unified managed approach. Alerts. The problem isn't that alerts exist, it's that email is potentially a bad channel for urgent alerts. So cloud monitoring alerting policies can be better at this. So there is PagerDuty and there's a PubSub integration that can send the alerts to on-call rotations and put in escalation logic, not just another email in a specific inbox. Managing multiple container environments consistently. So GKE Enterprise could be relevant here again with fleet management and config sync. This is similar to what we saw with Altostrat. So I'm just going to move on from that. Cloud build and cloud deploy, common pairing for the continuous deployment capabilities. Yeah, the case study specifically says something about rolling out new continuous deployment capabilities to update their software at a fast pace. That's classic CI/CD. So you'd think about cloud build and cloud deploy there. Outages from misconfigured systems. This comes pretty straight from the executive statement. The answer would be infrastructure as code, potentially with Terraform and config sync. So if your infrastructure is defined in the code, reviewed in version control, applied consistently, you would eliminate the manual configuration errors that cause outages here. You could also use deployment manager, but I put Terraform here because someone did recently tell me that Terraform showed up on the exam. So, and deployment manager did not. And so Terraform is just so popular that I wonder if Google is kind of rethinking pushing, deployment manager on their exams. And all you really need to know is that Terraform is an IAC tool. You don't need to know how to use Terraform. You don't need to know, the format of the YAMLs or the TOML files. You just need to know that Terraform is basically kind of the open source equivalent to deployment manager. And then finally, we've got insights and predictions on healthcare trends. That was a requirement as well. So BigQuery would be the data warehouse, Vertex AI potentially for the predictive models on top of it. This is the one place where AI might show up in the case study. It's a business intelligence use case, not a feature of their product. Okay, on to the last case study. I hope this is helpful. This is going way longer than I thought it would. Although we did talk for like 20 minutes in the beginning. All right, Knightmotives Automotive. So this is the biggest and most complex of the four in many ways, but interestingly, it's like the least technical in terms of what's actually in the case study. Sorry, give me a second. My throat's getting dry. Yeah, so Knightmotives Automotive. This is the biggest, most complex of the four case studies that are in the new PCA exam. But it is the least technical in terms of the actual architecture. And I actually don't have an architecture diagram here for this one because there really isn't anything in the case study about their architecture. So they make battery electric vehicles, they make hybrids, they make internal combustion engines or ICE vehicles. They're also investing heavily in autonomous self-driving technology. I also want to note here I also want to note here that their BEV fleet already has a modern AI-powered in-vehicle experience. So they're already kind of using AI, but the hybrid and ICE vehicles don't. And so it's those vehicles that are getting bad reviews. This is what's in the case study. And the sales are declining because of it. So there's a real business urgency to bring the hybrid and ICE models up to the same standard. The company is mostly on prem. Oh, sorry. The I have the I have the bullet point at the top here from the EHR slide because I copied the same format. So Knightmotives Automotive is a car manufacturer. They're not an electronic health record software company. You probably could figure that out yourself. Um, but the company is mostly on prem. They have apps scattered across cloud providers. They're not super specific about this. Their supply chain runs on an outdated mainframe. The build to order system where customers configure their vehicle has been unreliable. That's damaging their reputation and the relationship between Knightmotives and their dealer network, as well as the customers. The dealers have no budget for new equipment, so any tools that you build uh, need to work in a browser or whatever they already have. They've also had past data breaches, and so that's a concern that's going to come up. They need to comply with GDPR because they operate in Europe, as many car manufacturers do. And they have this big vision of shifting from being a car manufacturer to being an automotive experience company using AI. And they want to do that over 5 years. All right. So instead of an architecture diagram, I'm going to show you the raw text from the case study that talks about their existing technical setup. And I want to just make a few points on this. So we've got Knightmotives IT is largely on-prem, with some applications on major cloud platforms. Again, they don't say which ones. Their supply chain runs on an outdated mainframe, and their ERP is also outdated, making new promotions and dealer discounts difficult to implement. Dealers have no budget for new equipment. There is fragmentation across vehicles with multiple code bases and significant technical debt from supporting backwards compatibility. So network connectivity as well to manufacturing plants and vehicle connectivity in rural areas are also challenges. So that's just straight from the case study. So there are fewer technical details about the current setup. I think this means that questions are likely to have more details within them. So I wouldn't spend a lot of time reading this case study. And additionally, the solutions on the following slides are more speculative on my part. Okay. Consistent AI-powered UX across all vehicles, all models. Vertex AI would be what's used here for training and serving the models, potentially with edge computing on the vehicles themselves. The car would need to run inference locally because you can't depend on constant cloud connectivity while you're driving. That's kind of a classic, edge model, edge computing use case. Reliable connectivity in rural areas and real-time data. PubSub with a store and forward pattern potentially. So the vehicle would collect data locally, and then when connectivity is available, it would push that data to the cloud via PubSub. And then you could handle the data, the processing in whatever way is appropriate. Dataflow could handle the streaming data if it's a streaming use case. You're designing for intermittent connectivity here and not necessarily guaranteed connectivity. A personalized relationship with the driver is mentioned as well in terms of their in-vehicle AI and IoT needs. You could run personalization models on Vertex AI, storing the driver profile data in BigQuery. You could think of storing their seat preferences, music preferences, driving habits, route patterns. That's really the only solution I can really come up with there. Autonomous vehicle development and simulation. This would be heavy on compute. So you would use custom training on Vertex AI with GPUs and TPUs. And you could potentially use GKE with GPUs in the node pools for running simulations. Updating hardware and software in legacy hybrid and ICE models. So over the air updates, edge computing, we touched on this earlier. You push the software updates to the vehicle remotely rather than them coming to the dealer. Driving, road, behavioral, crash, data, insights, you would store that in BigQuery probably and run BigQuery ML, especially if it's highly structured data. And relational data, Vertex AI would be for the actual predictive models, especially if they're stored elsewhere or if you can't do the prediction that you want in BigQuery ML. And this ties to the executive statement in this case study about using data to enhance safety. Let's see. Data platform and monetization. So the corporate data is siloed. That's in the case study. AI infrastructure, their current AI infrastructure is obsolete. It's outdated. BigQuery would be the unified platform here to break down those silos. We saw a similar approach in one of the others. I think it was EHR or Cymbal, where BigQuery is the unified data layer, data platform. Vertex AI would replace their obsolete ML infrastructure, and these two, together are the foundation for everything else in this theme. Not much, specific here. Monetizing corporate data to fund investments. So you could use Analytics Hub for this. You can actually gather revenue from sharing data through Analytics Hub. This is a BigQuery feature that has shown up on exams in the last few years. And Knightmotives has valuable data about driving patterns, road conditions, crash statistics. Analytics Hub. First time we're talking about this today. Analytics Hub could be important for that. We talked about the third one already, basically, but it does tie to this, data platform and monetization theme as well. GDPR and EU data protection for autonomous platforms is another requirement. So the data residency controls would need to be applied in BigQuery on the data platform. DLP API could be applied on this BigQuery data set or data platform as well. And then scalable AI and ML infrastructure, that's just Vertex AI. That's its whole claim to fame, as being scalable and giving you all the infrastructure that you need for AI and ML. All right, this is a short theme. We've got preventing past data breaches. That could involve implementing security command center, or at least like catching them or being on top of the security needs of your environment. Comprehensive security framework and incident response. Again, I would say VPC service controls and cloud audit logs. Audit logs would allow you to look at the trail of who did what, and VPC service controls would create the perimeter so that data cannot be exfiltrated from the GCP environment. Protecting against cyber threats. Cloud Armor protects against DDoS and application layer attacks. And then again, customer managed encryption keys give you the control over the encryption keys so that even if someone accesses your data, they can't, even if someone accesses the storage service, they can't read the data without the keys. So one thing the case study also mentions is actually security awareness training for employees. I didn't put that here because that's more of like a people and process answer. And I'm guessing it would be a pretty straightforward answer. It's not a technology answer. It's just like, do more training. But I could see that being one of the rare questions where, it's a tidbit in the case study. And so you might have to, take a look at the case study, or they might repeat it in the question. And even though the knowledge that you need, the technical knowledge that you need, is actually not, very high to answer that. Dealer and customer experience. So they need to improve online build to order reliability, rebuild it on GKE with Spanner or Cloud SQL for the back end. I would say cloud load balancing in the front. Spanner is worth considering here because this is a global company and Spanner gives you globally consistent data, but Cloud SQL could also work if the question doesn't emphasize global scale. So it depends on the question. Providing real-time data transparency for dealers. PubSub is good for event-driven data sync. Firestore for real-time data store that dealers would potentially query, especially if the data is non-relational. And I suspect that the data about the cars themselves could be like a document store. But really this could be, any database. It depends also as well on their need for real-time synchronization. Firestore is good at that, which is also why it's used with a lot of user apps or web apps or mobile apps. But the database that should be used alongside PubSub in this instance would probably be named in the question. I think when I took the exam, actually, there was one that was, I think they said something in the exam that specified, or in the exam question that specified that Cloud SQL was probably what would need to be used. So that could, it could be pretty much any database, but that will be specified in the question because those kinds of technical requirements are not really specified in the case study as much for this one. Delivering modern tools without requiring new dealer hardware. We've got, this would be web-based tools only because they can't accommodate anything else. The case study says that dealers have no budget for new equipment. So that's an important detail. And it basically means, no hardware. Enhanced tooling for sales staff with service technicians. So this would mean probably a custom app somewhere, potentially on GKE, and then Vertex AI to do the actual diagnosis. You could imagine, for example, a mechanic distributing or describing a symptom. I'm having a hard time speaking now. Describing a symptom and getting predictions about what the probable causes are and repair procedures from like a Vertex AI model. That would be kind of next level, but I could see a question going in that direction. All right, this is the last slide. Adopting hybrid cloud strategy across on-prem and multi-cloud. So this is under the theme of infrastructure modernization. Dedicated interconnect. We've seen this in almost every case study. We would use that for the connectivity, and we would use GKE Enterprise for a consistent Kubernetes management across multiple environments. So we saw that with, I think it was Altostrat Media, and we saw it with EHR. That is something that definitely could show up on the exam. And then gradually modernizing the mainframe supply chain and ERP. So here I'm guessing the word gradually is pretty important. So I would say that the answer would be something like a hybrid connection now, but keeping the mainframe operational, and then you phase out the replacement of that over years. The exam may try to trick you into picking an aggressive migration option, but the case study does mention that this should be gradual. Upgrading the network between plants and headquarters. So dedicated interconnect for large plants would be good, especially with high data volumes. Partner interconnect could be helpful for smaller plants where there isn't that availability and low latency guarantee, or that you don't need that. And the choice would depend on the bandwidth needs per location. Consolidating fragmented code bases across vehicle types. You would standardize on containers. That would be using GKE with a shared services architecture. And so instead of separate code bases for each type of vehicle, like the battery electric vehicle, the hybrid, or the old style internal combustion engine, you would build a common service that all vehicle types share with vehicle specific logic as modular components. And this would reduce technical debt. At least that would be the idea. And it would make it possible to roll out features consistently across all models, which is what the CEO is asking for. That's a pretty cool question, actually, that I could see showing up on the exam, and like a pretty like intuitive, clever solution that feels sort of like a complex in terms of implementation, but is like intellectually satisfying. And that is all 4 case studies. So there are some patterns across all 4 of them, right? There's dedicated interconnect, GKE enterprise, mapping databases to their managed equivalents. The executive statement is pretty important. People tend to focus, I think, on the business requirements and the technical requirements that are explicitly listed, but the executive statement can also be important. And generally speaking, choosing the managed service and the cloud version of what they currently have over the unmanaged service, except where they say they don't want to migrate. Okay. You guys all pretty much know this is my email address, and you can reach out with any questions now.